Okay, the first thing we're going to do is talk about condensed chemical structures in organic chemistry. So on the left we have two examples of normal structures, and then on the right we have condensed structures. So notice in a normal structure we draw all of the bonds. Did you notice that, Cooper and Stockton? Nope, they didn't notice. Okay, Cooper and Stockton, I don't want you to talk through the whole notes, okay? All right, so when we have a normal structure, we draw all of the bonds. Also, we draw the lone pairs, okay? In a condensed structure, we do not draw the bonds between hydrogen and carbon. We also don't draw the lone pairs, and we also don't draw the bond between hydrogen and oxygen. So this is called a condensed structure. We still are showing the hydrogens. Next time we're going to talk about skeletal structures. Those are even more condensed. So you need to know the difference between a condensed structure and a skeletal structure. So today we're talking about condensed structures. Next time I'll talk about skeletal structures. Okay. All right. So what I want you to do is I want you to take this little packet of cards, and I want you to match the condensed structure to the normal structure. So you're getting a little bit of So there's a pair. Every card has a pair. Look for the condensed structure, match it to the condensed structure. Condensed to the normal structure.
I can see where I get myself into the structure. It's probably either like a 0 or oh, so then I know that's a definite no. That's a definite no. I'm pretty right. See, one is just like the expanded form of the other one. It's like math. Wait. Right. Oh, that one right there. I don't get why you're like I was just right. I am. No. Watch out. I am. I'm fine now. Normal and condensed. That's what you're separating them. Oh, you're separate? Oh, I thought we were matching like condensement. Are you separating them or matching? We're matching. That's why I was right. Oh my God. Gaslighting me.
All right, you got yours.
Yeah, I want to this one. Heck yeah. This is too easy. That's too easy. Oh, I've already matched one.
So what you're going to have to do is you're going to have to take a formula and draw either the condensed or skeletal structure. So it's going to tell you what kind of picture to draw. So keep working if you're working. Here is a key. So we're matching the normal structure, the normal load structure to the condensed structure. Ten. I don't remember how many are on the test. There's 10.
Are those common measures?
These are I just came up. Okay, how is that? You think you can do that? Does that make sense? Okay. So something to watch out for is even if the lone pair is not shown on an oxygen or a nitrogen or like a chlorine, those lone pairs are still there. So if it asks you how many lone pairs, you have to remember, oh, oxygen has 2 lone pairs. Nitrogen has 1 lone pair. A halogen, like fluorine, chlorine, bromine, or iodine, has 3 lone pairs. So you need to remember that. Okay, so looking at this molecule, this is our condensed structure. How many carbon to carbon single bonds are there? So just 1? So I see 2. So this hydrogen really should be off to the side. This is condensed. So there's a carbon to carbon bond, and there's a carbon to carbon bond. So there's 2 carbon to carbon single bonds. Does that make sense? Okay. How many carbon to hydrogen bonds are there? How many? There are 3. Good. So we have carbon to carbon or hydrogen, 2 of those, and then carbon to hydrogen. There's 3. Are we seeing those okay? All right. How many carbon to oxygen single bonds are there? Okay, I also see 2. We have 1 here. Carbon to oxygen. Carbon to oxygen. If this is a single bond, there's 2. How many lone pairs are there? 4. Okay, walk us through where you see 6. Okay, 2 on each oxygen. So there's an oxygen here, so there would be 2 lone pairs. We just haven't drawn them because it's the condensed structure. Okay, there's 1 more. Can you find there's 1 more lone pair? On the nitrogen, good. This nitrogen, even though it's not shown, it's still there to fill its octet. Oops. So we need to draw that. Oh, my pen is on. Okay, so there are 7 lone pairs here. You see that? Yes? Okay. All right. So don't forget, there's 1 lone pair on nitrogen, 2 on each oxygen, 3 on any halogens. Okay, the next thing we're going to talk about today is functional groups. So I found this diagram or little poster, and it has a whole bunch of different chemical functional groups. Alex thinks that you should know 8. So there's a whole bunch. If you go on Wikipedia and look up functional groups, it just has like a page. Like you just keep scrolling. There are a whole bunch of functional groups. Depending on what you're working with, you get used to the ones that you're working with. Okay. So these just start filling in your vocabulary as you use them. But what we are going to focus on is these ones, and these are on the handout. Okay. So there are 8 that Alex thinks that you need to memorize. If you don't memorize, then you need to fit them on your note card. Okay, so there's lots of things that you're either going to memorize or fit on one side of a note card for chapter 11 test. Does that make sense? Okay, so let's walk through these different functional groups and talk about what we're looking for. So when we're looking at a molecule and we're trying to identify what functional group it has, what we're going to do is we're going to look for anything that's special. Okay, so, and that will be the functional group. So in this molecule, if we have a molecule and we see a carbon bonded to an oxygen, a double bond to an oxygen, and right next to the carbon that's double bonded to the oxygen, we have an OH group, then that's called a carboxylic acid. So in our structure, they also use R as just a general term. That usually means that it's a carbon chain. So we have something else in our molecule. We don't care because we care about this carboxylic acid. So R can be a carbon chain. R can also be just a hydrogen. It depends on what molecule we're looking at. So we're just looking for a pattern. The next one we're going to look at is an ester group. So in an ester group, again, we see this carbon double bonded to an oxygen right next to an oxygen, And this is in a carbon chain. So we see this R group on both sides. So an ester group is in the carbon chain. An amide bond, this comes up in biology. So if you've heard of this one, maybe it's because you've taken biology. This one, we have a carbon double bonded to an oxygen next to a nitrogen. So that's what's really important. And then this nitrogen can either be connected to a carbon group, two carbon groups, or these could be hydrogens. Okay? But the important part is we have a double bond carbon to an oxygen next to a nitrogen. Okay. All right, the next one is an aldehyde. We have a carbon double bonded to an oxygen, and it's at the end of something. So it's at the end because we have a hydrogen at the end. So carbon double bonded to an oxygen right next to a hydrogen, that's called an aldehyde. Okay. All right, if we just have a carbon double bonded to an oxygen, and it's in the middle of a carbon chain, so this would be a carbon and this would be a carbon, then that's just called a ketone. We don't have anything else special next to the carbon double bonded to an oxygen. All right, and then the last three, we don't have carbon double bonded to oxygen. So if we have an OH group anywhere on our molecule, so it could be coming off in the middle, or it could be coming off in the end, this is called an alcohol group, OH. If we have an oxygen in the middle of our chain, so that's all we have. We just have some oxygen floating around. There's nothing else next to it. That's called an ether group. And then an amine group is where we have a nitrogen in the middle of our carbon chain. So we don't have this. It's not next to a carbon double bonded to an oxygen. It's just nitrogen by itself. And then these groups could be hydrogen or they could be a carbon group. Okay. So that's what we're looking for, right? Let's go ahead and practice these. And you have this sheet. Is there anyone who didn't get this sheet? Okay. So look at your sheet until you start getting really familiar with these. So this first one, what are we looking at? Oh, I also have it over here. You can compare. I also lost my mouse. Oops. Here we go. So what's special about this molecule? What do we have? What's different? What kind of group would this be? Okay, the top one says we have carbon double bonded to oxygen. That's true. And then the carbon that's double bonded to the oxygen has to be attached to an OH group.
Oh.
So it's close, but we don't have. So we have carbon double bonded to an oxygen, and then look at what's attached to the carbon at the bottom of the double bond. We have a carbon and a carbon. So what would that follow? Ketone. This one would be like a ketone. There's no other atom, like not really anything special. So watch out. I'm going to tell you that Alex likes to throw in carbon double bonded to carbon to try to trick you. We don't have anything yet that we care about that's carbon double bonded to a carbon. So if you have carbon double bonded to a carbon, right now you should ignore that. They're trying to trick you right now, okay? So only look for carbon double bonded to an oxygen, that's what we care about. Okay, so yes, this one would be a ketone. All right, how about this one? What do you see? What's special about that one? What functional group does it have? Good, this has an aldehyde. So we have carbon double bonded to an oxygen, and then right next to the carbon that's double bonded to an oxygen, we have an H. So that would be an aldehyde. So it takes a minute to start recognizing these, but once this would be a good one to practice. Once you practice this, you can start seeing them a little bit better. How about this one? What's special about this molecule, this third one? We have an alcohol group. Is there anything else? So some of these have parts of both, but they're only considered as one. Good. Top one. It's a carboxylic acid. So we have carbon double bonded to an oxygen. The carbon also has an OH group. This is on the end. This is a carboxylic acid. Good. Do you guys see that? You're starting to see that? Okay. How about this one? Down here at the bottom. think I heard it.
Alcohol.
Good, that's an alcohol. All we have is this OH group. There's nothing else special. That one's just OH. Good. Okay, how about this one up here? The top one on the right.
Ethan.
This one is an ether. Good. We have oxygen next to a carbon, next to a carbon. There's nothing else. Again, they're trying to trick you with this carbon double bonded to another carbon. We don't care. We just care about what's next to this oxygen. So that one's an ether group. Okay, how about this one? What's special about this one? This second one on the right. You don't want to say it?
I don't know how to say
Oh,
it.
this one is an amide bond. Amide. I've also heard of this as amide, but mostly I've heard of it as amide. And I could be saying it wrong. So we have a carbon double bonded to an oxygen next to a nitrogen, and then some other things. So the most important thing is we have this carbon double bonded to an oxygen, and right next to it is that nitrogen. Okay, how about this one? The bottom one. Good. This one's an amine. We have just nitrogen, nothing else fancy. That one would be amine. How about this one?
Ester.
Good. This one's an ester. We have carbon double bond to an oxygen. Right next to an oxygen, it's in the carbon chain. That's an ester. Okay. You feel like you could do that? Okay. And as you get more familiar, those you'll just start remembering those, especially if you use them. The more you use them, they're not too hard. Okay, the rest of the time, you should either be working on lab 13 or chapter 11, Alex, or we have our signature assignment. You could work on pre-lab for lab 5, which is on Friday, or you can work on the review for the final. So there's lots of things that you could be working on. Okay.